Energy powers everything, from the lights in our houses to the cars we drive,
or whatever you're currently using to watch this video.
Energy is always on the move, transforming from one form to another. But where does most of this energy really come from? Let's find out together in this episode all about fossil fuels. Fossil fuels are found in Earth's crust and contain carbon and hydrogen, which can be burned for energy. There are three major types of fossil fuels: coal, oil, and natural gas. Humans have been using fossil fuels for ever, but especially for the past 200 years, fossil fuels have been the backbone of human civilization. Coal gave life to factories and steam engines. Natural gas generates electricity and heats our homes. Oil literally fueled modern transportation and tons of everyday products, from plastics to medicines. Medicine from oil makes me feel a little uncomfy, not gonna lie. But what are fossil fuels? Spoiler alert, they aren't made from dinosaurs. I know. You're disappointed. I was too.
Fossil fuels were formed from prehistoric organisms during the Carboniferous period, or Coal Age, millions of years before the age of dinosaurs.
Sorry, bud.
300 million years ago, Earth was filled with shallow seas and covered with swampy forests. Tiny single-celled organisms called protoplankton floated in the ocean, and there were swamps and bogs like these everywhere. So what does that have to do with fossil fuels? We're getting to that. Energy enters an ecosystem when light energy from the sun is transformed into chemical energy during photosynthesis. Even ecosystems 300 million years ago had trees, ferns, mosses, and other photosynthesizing organisms transforming light energy into stored chemical energy. Plants can do a few things with the energy or sugars made during photosynthesis. They can break down the sugars to get usable energy right away, or store the sugar molecules for later use. If the plant stores the sugar molecules, it can then use them as a source of energy in the future, growing even when the sun isn't shining. The plant can also use the sugar molecules to build larger molecules, such as cellulose. Cellulose makes up the structure of the plant itself, becoming part of the plant's biomass. When the plant is eaten, its biomass provides matter and energy to the organism that eats it, like this rabbit, or grasshopper, or goat, or this crazy-looking thing that lived in the Carboniferous period. This is how photosynthesis fits into the energy transfer that we see in every food chain or food web. Again, what does this have to do with fossil fuels? When those organisms die, if they aren't consumed, that stored energy doesn't just disappear. It's trapped in its biomass. So when these living things died over 300 million years ago, they sank to the bottom of the ocean or the bottom of the swamp, and over millions of years started decomposing under layers of sand, clay, and silt. As new sedimentary layers were deposited over and over again, like this stack of books, the layers put tremendous pressure on the sediment and organic matter. At the same time, Earth's interior provided intense heat. Over time, this combination of heat and pressure transformed these materials, the biomass, into the energy-rich substances we use today. Different types of fossil fuels formed, depending on the combination of organic matter and external factors, like what animal or plant material was present, how long the organic material was buried, and what conditions of temperature and pressure existed while they were decomposing. Coal formed in ancient swamps where dead plants accumulated faster than they could decay. Coal is usually found in sedimentary rock deposits, where rock and dead plant and animal matter are piled up in layers. Oil and natural gas were formed from organisms that lived in water and were buried under ocean or river sediments. Oil formed first in most areas, but deeper underground, exposed to more heat and pressure, natural gas formed. Natural gas is usually found in pockets above oil deposits. Because the gas is less dense, it makes its way above the oil. If you're still here liking this video, let us know, and hit that subscribe button so you never miss an episode.
Fossil fuels are excellent sources of energy because they have a high energy density. When fossil fuels are burnt, the chemical energy is released as thermal energy. In power plants, this thermal energy boils water, creating steam. That steam spins a turbine to make electrical energy. In transportation, the fuel reacts with oxygen inside an engine and combusts, creating mechanical motion. Fossil fuels are also easily stored and transported, allowing them to be used to power a variety of things at almost any time and anywhere. Like we said earlier, fossil fuels have been the star of energy production on a large scale for hundreds of years. But unfortunately, fossil fuels are a non-renewable resource. This means that sooner or later, we will have mined the last of the coal deposits and extracted the last of the oil and natural gas. Waiting millions of years for new coal, oil, and natural gas to form isn't really an option. The good news is there are renewable types of energy like solar, geothermal, and hydropower. To learn more about these options, you can check out this video.
I think it's important to realize that even though fossil fuels work great to power everything that we currently need, there is a cost or a downside. Burning fossil fuels releases carbon that took millions of years to accumulate into the atmosphere every year. All this extra carbon in the atmosphere has to go somewhere. Over time, plants, soils, and the oceans will absorb most of the carbon dioxide, but 20% or so may remain in the atmosphere for thousands of years. Carbon dioxide is a greenhouse gas that absorbs energy, including infrared energy or heat emitted by the Earth, and then re-emits it. This energy travels out in all directions, some returning to Earth, where it heats the surface. The extra carbon isn't the only issue. Mining for fossil fuels can decimate landscapes and ecosystems. Accidental oil spills contaminate oceans and shorelines, harming marine life for years. Hydraulic fracturing for natural gas has the potential to contaminate groundwater and trigger earthquakes. I think everyone would agree that none of these things sound great. For now, fossil fuels are the main energy source powering homes, businesses, and vehicles. Yes, even those electric ones. Fossil fuels are being used as soon as you plug them in. Eventually, we will have to rely more heavily on alternative energy sources. But until then, remember, fossil fuels didn't come from dinosaurs. And if you want to learn more science, you can check out this video next.
You're still important. It's okay.
Bird with swampy. I'm in my head now. I feel you looking at me. 3, 2,